Hey everyone, Chris Dingman, Math and Science Explainerator, offering online tutoring at www.achievewitheasetutoring.com. This is a video for people who are maybe just starting algebra or are into algebra and feel kind of intimidated by the whole topic, maybe by math in general. This is going to help you have a really firm foundation in what algebra is kind of all about, the fundamentals of why do we got to get letters involved in math? We thought math was about numbers. Lots of people at this point start to get a little confused or at least intimidated, and then that just causes more confusion when we start bringing letters into the game. But after this video, you're going to feel totally confident to move forward in algebra. All right, so I'm doing this video. Why do we have to start getting letters involved when we get into high school math, algebra, algebra 2, trig, calculus, all that? And I want to take some of the mystery out of it, maybe some of the intimidation some people feel when they hit this math that involves letters, because a lot of people feel comfortable with math when it was just numbers, like 6 times 2. Okay, we can visualize that. That's 12, or adding 8 plus 1 is 9, and all that stuff. And dividing fractions or simplifying fractions, 10 over 5 is 2 over 1, and that's 2. And then adding, subtracting fractions and all that stuff. So why get letters involved? Well, first of all, we're not really getting letters involved. We're still dealing with numbers, but letters are just standing for numbers. So the first thing is, don't be intimidated. You know, if you see x plus 2, that's just some number that we don't know yet, plus 2. It's really all there is to it. Now, if x is 1, then 1 plus 2 is 3. So it's still pretty simple. When you see a letter, don't get intimidated, don't get thrown. I want my videos to not just answer your questions, but give you a foundation so that you don't have to ask people questions or as many questions. Of course, we're always going to be asking people questions. There's always more we want to know. That's true for anyone. But ask fewer questions about, can I do this? Like, don't look to an authority, another person. Oh, they're good at math. They'll tell me if I can do this. I'd love if you could just ask yourself that first. So, for instance, if you saw x plus 2, and you wanted to know, could I say 2 plus x? Could I write it that way? Well, yeah, because is 1 plus 2 the same as 2 plus 1? Yeah. So lots of times, if you want to know, can I do something with a letter when you're looking at one, just slap a number in there and ask yourself, is this how numbers work? So does it matter what order I add something up in? No. 3 plus 8 is 8 plus 3. Same with multiplication. If you saw 9x, could I write that as x times 9? Okay, when you just see something next to something in parentheses, it means times. And in algebra, when there's nothing written between two things, it means times also. So 9 times x is 9x, and here's also x times 9. Are those the same thing? Yeah. It doesn't matter what order you multiply things in. All right, what if we had 6 over x? Okay, that just means 6 divided by, that's what that bar means, divided by some number x that we don't know yet. Could I write that as x over 6? Is that the same thing? Well, I don't know. Slap a number in there. 6, let's say x is 2. 6 over 2, 6 divided by 2 is 3. But what about if I had 2 over 6? Well, that's different. That's 1/3. Because it does matter what order you divide things in. 6 divided by x is not the same as x divided by 6. So a lot of people just kind of freeze up. They get intimidated by math. And that just keeps us, when we freeze up, it actually keeps us from calming down and trying some things, experimenting. All right, now, why do we involve letters? Why can't we just keep math using numbers? So let's talk about that for a minute. It's really about change, because when you start to get into math above just calculating, adding, subtracting, dividing, multiplying, you actually are starting to think and model change. Things are always changing after all, right? For example, you're driving down the freeway, your distance is changing, and your time is changing. So we need numbers that can change, or we need a place where we can, kind of like a slot where we can put different numbers because the numbers are changing. And another word for change is vary. So vary. Because things vary, we need variables. Okay? A variable is those nasty letters that you see in algebra, except think of them as friendly now. Okay, so here's just a variable can be anything. It could be a picture of a house, but that's, it takes a little while to draw. So really, it's just a spot where you can put a number that we want to vary or change. That's why we have variables. So to go back to that example of distance and time, you have an equation. An equation, remember, comes from the word equal, which is hiding in there. An equation has an equal sign, period, end of story. So when I say 3 equals 3, that's an equation. When I say x equals 3, that's an equation. When I say 8x squared minus 16p over 9w plus 5 equals 1, that's an equation. If it has an equal sign, it's an equation. All right, so again, don't want you to be thrown by, not knowing what words mean. And a lot of people actually lose track of that. They lose track of the difference between like an equation and what we call an expression. An expression is just any mathematical thing that doesn't have an equal sign. So like this is an expression. I know I'm kind of getting sidetracked here, but I hope you don't mind. That's an expression. That's an expression. Expressions are just anything mathematical that doesn't have an equal sign. But when I set two expressions equal to each other, now I've got an equation. That's really all there is to it. So let's go back to variables and equations and this whole change thing. So we're going to use variables and an equation to think about someone driving down the road at, let's say, 50 miles an hour. Okay? For now, we're going to keep that constant. 50 miles an hour is not going to be something that changes. It could be in another equation. Obviously, sometimes we go at different speeds. But for these purposes, 50 is going to be what we call a constant. And these are like the two basic things you're going to meet in high school math are constants and variables. And their definitions right there in the word. A constant doesn't change. It stays constant. It's otherwise known as a number. So 50, it's a number. It's constant, right? It's not sometimes 26. Variables change. They're represented as letters. They're just places you can put different numbers. Okay, I'm repeating myself a lot here, but that's okay. We're driving down the road at 50 miles an hour. Let's make what we call a table of values. You're going to see these a lot, and they're really key concepts in math and in algebra because, well, you'll see. So I'm going to make a table of values. In the first column, I screwed up. The first column I want to be T, standing for time. And the second column is D, standing for distance. So obviously time goes by, have you noticed? So let's say you're driving down the road. Let's say 0 time has gone by. How far have you gone? Probably not too far in 0 hours. By the way, time is in hours here. We just happen to be using hours. We could use seconds or minutes, or eons, I suppose. Now, after 1 hour has gone by, how far have you gone? If you're going 50 miles per hour and you drive for 1 hour, you've gone 50 miles. And on this goes, if I go for 2 hours, since I'm going 50 miles every hour, if I drive for 2 hours, I've gone 100 miles. All right, after 3 hours, I've gone 150 miles. So time and distance are varying. Therefore, they need to be represented by variables. Now, math in high school and algebra, and as you move up, in a lot of math is about change and patterns. Okay, so let's demystify the whole thing. It's about how do things change and in what pattern. So, pattern here is that it looks like I'm multiplying my time by what number? The pattern is I multiply by my time by 50. And that's no coincidence. I'm going 50 miles an hour. How do we represent that mathematically? Well, in an equation, we'd say my distance equals my time times 50. All right, so again, when you write something in parentheses next to something else, it just means multiplication. Now, in algebra and in math, we generally don't write it T50, we write it 50T. It's less work, no parentheses. I like that. Distance equals 50 times time. That's the pattern in this situation. If you're driving down the freeway at 50 miles an hour and you want to know how far you've gone after a certain amount of time, this is the pattern. You multiply the time by 50 and that will spit out the distance that you've gone. Now, this becomes a handy little equation. Because say I was going to be driving for, I don't know, I'm a maniac and I'm going to drive for 11 hours straight, and I'm going to go 50 miles an hour. So, of course, this is a very simplified example, and you're never going to drive exactly 50, and hopefully not for 11 hours straight. But just for the sake of demonstration here, I'm going to drive 11 hours straight, and I want to know how far I'm going to go. Well, of course, I could just keep putting numbers into my 0, 1, 2, 3, and I could keep adding 50 because to the distance. So add 50, add 50, add 50 11 times, because that's also the pattern, right? You add 50 to the distance every time you add 1 to the time. So, but instead of cranking that out up to 11, what equations allow you to do is simply put in 11 for time. So instead of 50 times t, t is a variable that just stands for a number that we don't know yet. Remember that. Just keep remembering. Letters are just numbers. We just don't happen to know what they are yet. So do I know what 50t is? No, because I don't know what t is as a number. But once I tell you, okay, t is 11 because I drove 11 hours, now we know the distance is going to equal 50 times 11, which is 550. So I can drive 550 miles in 11 hours if I'm going at a constant speed of 50. Okay? So the letters are variables, and the number 50 here, it's actually when you stick a number in front of a variable, we call it a coefficient. So I'll just throw that word at you if you ever see that. Again, we see these kind of fancy looking new words, but don't get thrown by it. A coefficient is a number sitting in front of a variable, multiplying by that variable. Okay, now the cool thing about equations is you can put in for distance and find out the time. So I could also say, like, how much time will it take me to go, I don't know, 900 miles, okay? This time I know the distance, and I want to know the time. So I'm going to put in 900 for, let's see, let's move this over. All right, so I'm putting in 900 for the distance this time. That's the variable that I now know, and now I don't know the time. Now we could solve this equation right here, for time. We could figure out what t has to be to make distance 900. Now this is a simple equation, so you can just look at it and say, what number do I have to multiply 50 by to get 900? And you might be able to figure out from there. You could try some numbers, or just however you do it, you could say, oh, t has got to be 18. I have to multiply 50 by 18 to get 900. And then also, you may have learned that the way you do this is, and don't worry if this isn't familiar right now. Just for the purposes of a quick demonstration, what we would do here is we would divide both sides of the equation by 50, okay, and that's going to cancel out this 50 and going to give us t equals 900 divided by 50, which is 18. So time equals 18. So once again, does it matter if I say 18 equals time or time equals 18? Nope, I can switch sides, no problem. So I would have to drive 18 hours if I want to go 900 miles. So again, you may or may not know how to solve equations, but that's not my point here. My point here is just, what is a variable? Why are they useful? Why do we got to get letters involved when we're doing math? I thought math was about numbers. It is. Letters are numbers that we don't know yet. All right, that's really what I wanted to cover in this video. And what I want to do in general when I explain math and science is demystify it and give you the tools, concepts, whatever you call it, for you to have this foundational sense of confidence in moving forward and not be intimidated by any of this stuff. Now, if you want to keep watching the video, I'll just show you a little bit more of a complicated equation, and you can stick around and watch that, because you might be thinking to yourself, well, d equals 50t, I can just kind of do that in my head. I don't need to write down an algebraic equation to do that. So maybe you're not quite convinced yet that math is all that useful. So I'm going to show you a more complicated equation where you really do need to write it down. At least I do. Most people, I think, would. And that's for the situation when you're throwing an object up in the air, whether it's like, from a cliff or standing on the ground throwing it up. There's an equation that relates the height of the object to the time that's gone by. All right, now this is more complicated because the object goes up and then it goes down, and we're involving the speed at which you threw it and the force of gravity pulling down on it. So let's look at what that looks like. Okay, so we're modeling the situation where you've got someone standing on the ground. There's the ground, here's someone, and they've thrown an object up in the air, a little red ball. Boom. It's going to come back down and hit the ground. All right, now on planet Earth, where there is a certain force of gravity, we have an equation that does a pretty good job of telling us how high that ball is going to be after a certain amount of time, according to how fast you threw it. Okay? So the height is equal to negative 16 times squared plus the speed, or let's say velocity that you threw it, velocity is just speed, times the time again, but not squared, plus whatever height you started at. So I'm going to call that, I don't know, level, L for level. Lots of times you'll see like variables like h sub 0. That's just a number. Again, it's just telling us the height at time 0, which is like saying the height you started at. I'm calling it L for level. It really doesn't matter what letter we use. So again, don't get thrown by all these little symbols or letters. So let's say, and by the way, negative 16 is about how strong gravity is on Earth. And that's in feet per second. Now the numbers I'm using here, or the number 16, is assuming that your height is in feet and your time is in seconds. So we're using feet and seconds. In physics, they often use 4.9 for this 16 because they're using meters and seconds. So it depends on the units you use. So basically, if I'm throwing something up in the air and letting it come back down, I can use this formula to predict what height it will be at whatever time I decide to plug into this equation. Okay, now it looks like there's lots of variables here, right? It looks like there's an h, a t, a v, a t, and an l, but there's really only two because the v is something you're going to know. So like for instance, let's say I threw the ball up at, I don't know, 20 feet per second. I don't really know what's realistic. That's probably too slow. So let's make it 80 feet per second. Maybe that's too fast. Ay, ay, ay. All right, so that's my v. That's this v right there. That's going to be known for a particular situation. So the height, we could say, is negative 16. That's gravity. That's the force of gravity. Times the time that's gone by squared, plus the velocity I threw it at, which is 80 feet per second, times the time again, plus the height that I threw it from. If I threw it from ground level, I started at 0, so that's just a 0. L is 0. So you see how there's just two variables here. And if I input a time, this will output the height at that time. So if I want to know how far has this ball, how high has this ball gone after 1 second, I would just put a 1 in for the time. T is my variable. It varies. In this case, it's 1. Now, after that, you're just calculating. It's negative 16 times 1 squared plus 80 times 1 plus 0. This is going to give me the height of the ball after 1 second. 1 squared is 1. Negative 16 times 1 is negative 16. 80 times 1 is 80 plus 0. Height equals negative 16 plus 80. That's 64 feet. After 1 second, the ball will be 64 feet in the air. So you can see how these are really handy, you know, for rockets going off or whatever it might be. Mathematicians really like equations. Well, so do engineers. All right, let's do another time. So we know after 1 second has gone by, the ball is at 64 feet. Let's see what happens at 2 seconds. Well, that's again the beauty of these equations. We can change the number from 1 to 2. We didn't used to be able to do that. But we have variables that vary. T is our variable. We're going to put in 2 seconds this time in that T slot. The T is just a slot. It's a place to put a number. And often it's any number you want. So we're going to put a 2 in. Let me erase some of these numbers here. Okay, putting in a 2 for T because we want the height at 2 seconds now. So our handy dandy formula is going to give us the answer. Now we have to square the 2. 2 squared is 4. Then we're going to be multiplying that by the negative 16. And then 80 times 2 is 160. And again, it's plus 0, so that doesn't matter. All right, now we have to do negative 16 times 4. That's going to be negative 64. And then 160 plus that. So negative 64 plus 160 is 96. So that means after 2 seconds, the height of the ball is 96 feet. So let's just put these numbers in the diagram here. So after 1 second, let's just say here's a moment in time of 1 second. The ball was 64 feet in the air. That was the last calculation. And then now it's 96 feet in the air. So I don't know, put 2 seconds here. I'm not being very exact here, but the ball went up. It went up to 96. And then, of course, we could keep putting numbers in for time and keep getting heights. And we expect the height to come back down, right? So let's just see if that happens. Let's put in 4 seconds. Now, I don't think my numbers are very realistic. That 80 feet per second, maybe that's a bit fast for someone to throw. But maybe it could be a cannon or an arrow or something like that. So now we put a 4 in for our time. So the letter T is just an empty space, sort of, for a number to go. And this time we're going to make that number 4 because we want to know the height at 4 seconds. And 4 squared is 16. 16 times negative 16. 4 times 80 is 320. Plus 0, who cares? All right, negative 16 times 16 is negative 256 plus 320. And that happens to be 64. We get 64 again. Well, that makes sense because let's say this is 4 seconds. Again, this scale, everything's, not accurate, but just to show you what's going on. At 1 second, we are at 64 feet, and the formula is telling us at 4 seconds, we're back at 64 feet. And that makes sense because balls go up and down. So I hope that helped you feel comfortable going into algebra. Remember, always go back to basics. This is something that in classes often is not done enough. Students get lost in all these details, and they feel like they need to keep asking the teacher or whatever, just not knowing something or having to memorize all this stuff. But I want you to always go back to the basics, the fundamentals, because that's what helps you actually build confidence and success in math. Always keep in touch with what the basics are. I think I've said that enough now. Okay, see you in the next video.